Eldritch, congrats on the first. Oh, yeah. Wait, how many firsts? 28, not bad. Man, Spectre is just cracked. You're busy becoming God? Go play Minecraft or something? I don't know, I haven't heard Minecraft before. It's a good one. Okay, so last time I was trying to learn about Fourier. It's from oh, Deltarune. Okay, I've heard of Deltarune. I don't know anything about it though. Okay, so last time I was doing this, last time I was streaming, I was working on this example problem, and I got stuck on doing the inverse because, and it's a little bit harder integral. Let's try and work through it though. I have two journal plus pluses open. Why? Okay, good. I better find the inverse formula. I'll just pull them both. Okay, so we should theoretically be able to take this result of the Fourier transform, plug it in here, and get the original f of x back. So there's a pole at IA and at minus IB. And we want the integral from negative infinity to plus infinity. Hey, collar cone. And so the book evaluates one contour integral with the upper semicircle, another contour with the lower semicircle. I guess we'll do the upper first. Man, every time I write DK, I'm gonna think of the Donkey Kong rap, like DK, Donkey Kong. Calculate how many fireballs you missed. 0, because I'm an elite major arena gamer. Why can't I remember? This is bad. Like, uh, the residue theorem. Hey, Joseph integrates, and hello, Amorphous. Okay, 2 pi I times the residue. I don't know why I couldn't remember that. Nobody's here. Hey, it's going good. How about you? It's good to hear. Also, we need to get a common denominator to quickly get the residue here. I bet there's some trick you can use to like not have to do this. But let's get our common denominator and just see what happens. Right, so just b plus a. Okay, so if we want to get the residue, I'm working through an example problem the book was doing, Joseph. Basically, Slim, thank you so much for the raid. Welcome in everyone. Kishimita, hey, welcome in. Hope you're doing good. Yeah, so Joseph integrates. I'm working through an example problem book for myself. Basically, it starts by finding the Fourier transform of this function here. I did that last stream. And then I wanted to verify that taking the inverse transform does give you the original function back. So that's what I'm working on right now. And so I'm using this formula to do it. But the integral is, ooh, I'm messing this up. I made the wrong integral. But yeah, I'm trying to do the inverse Laplace or Fourier transform of that. But yeah, Slim, I hope your stream was good. Welcome in, everyone. Do you know how to do vectors? Sorry about my mic. With matrices, vectors like matrices with intersection of 3 planes and stuff. Yeah, I think I know what you're talking about there. If you want to just put a question in chat, I can tell you like yes or no. I do generally know about like vectors and matrices and stuff. The only thing I'm like thinking about in my head is the intersection of 3 planes, but I think I know what that would mean here. Solving number theory problems, my favorite. True. Nice. Okay, so the thing that I set up incorrectly here is I forgot to tag on the e to the ikx. That's what makes the integral not really easy to solve. Hey, Lucas. People give us credit only for what we ourselves believe? I don't know what that means. That sounds like a really bad fortune, though. I remember you said you have something to share with us. You put it in chat? Okay. Or I don't see it. Everything we know, we believe, therefore people give us credit. That doesn't make sense to me. Okay, I just got back into calc, realized how much I hate first principles. Yeah, it's really making a challenge for yourself if you're trying to do everything from first principles. Calc goes a lot smoother if you kind of strategically don't use first principles and just rely on intuition for some parts. No, Lucas, it's just a study question here. And nobody's here. I still don't see your question, I guess. If it involves a link, YouTube just won't allow it. Oh, wait. Why do I see it in that chat up there, but not in my actual chat? Oh, it was being held for review. Oh, I see, Jed. Thank you for looking at that. Now, why does that not show up in my... So I can see it when I go to this tab, but in my actual OBS, I can't see that message that was held for review. That's an issue. Moderation activity? Oh, there's a slider I didn't have toggled. Now I can see it. Okay. We're learning. You want to say limit definition of derivative is intuitive? That is it. I think it's intuitive. I wouldn't say everything is intuitive though. Oops. Oh no. You found an inverse of your wedge. You did the same definition, but instead of a minus b. So that, are you sure that it's a true inverse? Because you would have an issue with 3 wedge 2. It's the same thing as 3 wedge 1. And so if you just have the result, what would your inverse give you? It's not a true inverse. Okay. It's a different thing you can work with. Okay, that's fair. Yeah, sure, amorphous. So yeah, nobody's here. Like, what do you want to hear about this problem? Like, do you want me to just show you how you would solve it, or is there something else that you're trying to get at here? Two is supposed to be on the x. In equation 2. Oh, I see. Okay. That makes it a lot. Yeah, that 62 was kind of random, wasn't it? Just seeing different strats to speed it up because they're really easy to make mistakes in. Okay. Yeah, unfortunately, there's only so much that you can do. It's just a really delicate thing. And if there is a way to avoid making mistakes, I haven't found it. I don't have much of a better way other than like, you know, doing the augmented matrix, and they probably show you. Like that. And so the key is to get zeros in that like triangle there. And so we kind of work on it on like one column at a time. So I'm going to take row 2, subtract off twice of row 1, and then take row 3, subtract off just one of row 1, because 2 minus 2 is 0, 1 minus 1 is 0. And so, like, keeping good records of what you're doing can help with this, but this is just doing a lot of arithmetic, and there's no real way around it. Oh, yeah, don't trust ChatGPT for actual like calculations. You have a book somewhere, but it comes down to something wedge something. So a that b is min of ab minus 1. Really? So this isn't like in inverse as I would imagine it. Lucas would be like your operation takes two numbers like 4 wedge 3 and outputs just one number, in this case 5. I would expect an inverse to be like you take the 5 and somehow find 4 wedge 3. Is that I guess that's what it will be like. But you am I thinking about this wrong? I mean, but you could also just define a different operation that's like you say, which is um oh, okay, and so that's okay. I think I see what you're saying now. Then I might be thinking about the word inverse is really tricky in math. I might be thinking about it in the wrong in the wrong way. But if you have this like I don't know, like minus wedge thing, or I don't know exactly like if you write it like that or not. You're saying it's the min minus 1, so it'll give you 2. So when you have bigger coefficients, yeah, it is. So instead of using ChatGPT for calculations, I would recommend to use Wolfram Alpha. It's going to be way better. If I just enter these 3 equations and put a semicolon between them, I bet it'll know what to do with it. So it is 1, 2, 3, as I think Joseph said. Wolfram Alpha, they charge money for the premium features, but it's free. Like the important bits are free. ChatGPT made the question and gave you the answer. Okay. But that's exactly why you should be careful with ChatGPT, because it gave you the wrong answer. So you potentially would have like been fed bad information if you trusted it too much. If you want stuff like this, I was just looking for practice problems like this for someone else who was asking about it. I don't know if there'll be that many, but I'll put the link in chat here. There's not as okay. Never mind. There's not as many practice problems in here as I would have hoped, but I bet oh my god, what's it called? OpenStax. Free online textbooks. They should have systems of equations in one of these books, and these are completely free. And unlike ChatGPT, they won't randomly be wrong. Well, they might have like typos, but not as much as ChatGPT would. If I was rich, I'd buy you all these textbooks. Oh, well, these textbooks are free. But hello, Sage. Appreciate the kind words. For this, you also found something equal to a plus 1. So now equals speed is defined for all n except 0. Okay. But yeah, so I assume it's not going to be helpful for me to go through the entire problem here. So I'll give this example here a rest. But the moral story is there is not a good way to simplify this, as far as I know. You just have to be careful with it. Yeah. So yeah, Amorphous, you said you wanted to ask a question as well. Feel free to drop it in chat. So I'm still trying to think about like kind of this new operation that you're doing here. So is the point where if I do like 4 wedge 3 and then like minus oops, and then like minus wedge 3, do I just get 4 back out? Is that the idea? No. Yeah, so I can yeah, sounds good. I can see where like, you know, min is the inverse is kind of like the opposite of max. But yeah, that I'm still trying to wrap my head around like if there is a relationship between those two. Like I'm trying to like search for there. All good? Okay. Got it? Okay. Oh wait. Oh wait. No, okay. So if I did 4 wedge 3 inverse wedge 4, assuming we go left to right here, we get 5 inverse wedge 4, and that is 3. Okay. Okay, so that, no. Okay, so it gives us like a result that we can expect, I guess. Okay, yeah, and so it's useful for solving the +1 and -1 issue. So this would be 3 wedge 6, which is 7. Okay, neat. If b is greater than a, then it's b minus 1. So, okay, if we have, say, 4 wedge 6 inverse wedge 4, we're saying we should get b minus 1 here, or like 6 minus 1. Sounds good. No, nobody's here. Thank you for the question. I'm getting 3 here, right? Post it in Discord? Okay. Hey, Aditya. I'm doing good. How about you? Come on. Here it is. You got to study hard. Only 160 days left for the entrance test. Oh, well, you still had a good amount of time, but good luck with your studying. Hey, $10. Okay, so these are the two things we just talked about before. A wedge A inverse wedge B. Let's do an example. So is this 5 inverse wedge 7, which is 4? That's not quite right, is it? Wait, so that's not a... That doesn't match this, right? Wait, no, that's for a greater than b. For a less than b. No, it's still not right. Actually, this is the one... If they're the same thing, this works differently, right? This is 4 plus 2 is 6? Which is 5. That's still not... We're expecting 6. So yeah, maybe there's a mistake in there. Uh, I forget, because I know this is what you were initially doing, but is if you have like the same number, like is 4 wedge 4 still 4 plus 2? Yes? Okay. Um, yeah, so we should be able to do that one in general. So if we have a wedge a, inverse wedge b, we know this bit here is always a plus 2. Well, ooh, you could have an edge case. What if a plus 2 equals b? Then it's a. Oh yeah, okay, yeah, because, okay. Yeah, okay, that makes sense then. So you might even want a third case for these if, well, I guess a plus 2 is the important bit. Okay, syntax. I can't judge for handwriting. You had a slow day at work. It was too hot to get much done. Dude, when it's hot out, I do not want to do anything. I guess that's what I might say for this. Or sorry, not. This is an a. This is a plus 2. So that was damn near nocturnal, I bet. To bed at 7 a.m. Jeez. Hey Felix. This is an algebra that Lucas has been like playing with. Basically, we've just been calling it wedge. If you have, it started, oops, with like, if you have a wedge a, b many times, then this is a plus b. And if you have A wedge B, then it's max AB plus 1. And so Lucas has just been kind of trying to investigate this. Apparently someone else has like done it first, but he's just been like curious about trying to find properties about this. And the thing he's just shared today, well, aside from a whole bunch of possible like properties here, is that he's also defined this kind of like inverse operator. That's A plus 2. So there's an inverse one, which is A minus B. Or if they're different, then it's the min minus 1. Adia, if you want, you can try me. If it's JE, though, I probably can't do it. Oh, geez. Hey, Phobos. Hope you're doing good. Yeah, it's defined differently for if you're plugging in the same numbers or not. Yeah, I'm doing good. Is this a Pythagorean? Isn't that secant? Yeah, that's secant squared. Also, you're saying you can't use is L'Hopital's just not allowed? Because L'Hopital's, I think, does a well. Yeah, L'Hopital's applies. One to the infinity is indeterminate. Although we can also say that it's this. Nope. Well, L'Hopital's also works for 1 to the infinity. So Wikipedia article for indeterminate forms, they're all right here. So like the first two are the most common, but 1 to the infinity is another one. Can we do L'Hopital's from the secant? What is secant of 0? Secant goes with cosine. So that's just 1. So this is 1 to the infinity. You can L'Hopital's from here. And so what we have to do is exponentiation. I'm going to make this e to the ln. And the 1 over n just kind of stays put. And then the trick here is that the limit can come up to the exponent. There's other ways of thinking about this too, but they all boil down to be the same thing. And so now this is something that you can definitely L'Hopital's. Um, minus ln cosine. Oh yeah, we can also. Actually no. I'm not gonna bother, but actually yes, I would. I guess I will bother. No, I won't bother. I don't know. But yeah, from here you can do L'Hopital's now. So the derivative of the numerator, 1 over secant root n. How did e? It's because it's a trick you just have to know with limits that involve exponents like that. E to the power of a ln b. Let's just say e and ln are inverse operations. It's the same thing as b to the a. And so I just did I went from this side to this side. And it's because this is a way more convenient thing to like work with. But it's just a property of exponents. Way too busy to stream. Unfortunately, I'm too busy this week and next week too. Busy bee. Okay. So yeah, it's just a good thing to know when it comes to doing limits involving exponents, derivatives too. So yeah, I did L'Hopital's on this thing up here. It's 1 over secant root n times the derivative of secant root n. So secant root n tan root n times the derivative of root n, which is 1 over 2 root n. Annoying. All divided by 1. The derivative of n. This is the only question in Q syntax besides just kind of like the conversation with Lucas. So if you want, you can ask it. Hey, I'm Janie. I'm doing this problem that's at the top here right now. The secants cancel. Tan root n over 2 root n. Tangent of 0. Oh, we get 0 over 0 again. So I guess we L'Hopital's again, and hopefully it works out this time. Tangent goes to secant squared. This should work out. Secant squared root n over 2. So secant of 0 is just 1. So we get e to the 1/2. So I'd say that's the answer there. Secant of 0, yeah. And if you're talking about like this stage here, it secant of 0 is 1, and then ln of 1 is 0. And Lucas, like, where are you stuck with like revising these things now, or what's up? It should be e to the 1/2. Yeah. When swapping order of integrals okay, and how to do when the inner integrals depend on the integration variable of the outer. Oh yeah. That's a pretty common thing to make you do in multivariable calculus. No worries. But yeah, L'Hopital's works for any indeterminate form. The only thing is, if you don't have one of the first two, you need to make it look like a fraction. So if you have any of these over here, you need to like manipulate it until it becomes a fraction. So that's what we did here with the exponent trick. You don't know what new stuff to do. I don't know what new stuff to do either. Like what new stuff to explore with this. Like you could try taking functions of these, like what happens if you square it or something, I guess. But I don't know. Okay, let's look at syntax errors. Finally, a problem that I can probably actually do here. You basically have to take the bounds of the integral and re-express them. Okay, and so I guess the point here is that doing the integral in terms of x first is very difficult. I did. I hope I mentally rendered the LaTeX correctly. This is the only LaTeX renderer I need, apparently. Yeah, doing x first would be a pain in the ass here. And so Anakin speaking with R2 in the prequels. For when it's okay to do, it's something to do with continuity. I don't remember the exact condition. Oh yeah, yeah, that could be cool sometime. And so let me remember how this goes. So the region that we're looking only at the x parts first. The x's are going from 1. Root y looks like, wait, if x equals root y, that means y squared, or wait, x equals root y. That's just a regular parabola. Yeah, I had it right the first time, but only half of it. It's that. Okay. So x is going from 1 out to root y. Isn't these bounds don't seem to make sense to me. Y is going from 0 to 1. Isn't one of these backwards? Yeah, because if y is going from 0 to 1, it means we're integrating over this region here. And so we're really going, x is really going from root y out to 1. So that's a little bit weird. By the interpretation of an integral like this is it's the volume underneath the three-dimensional surface, I believe. So if you have just like some three-dimensional surface, I should draw this in a different color. We're finding the volume that is underneath like this little region here. And so we can express this with whatever variables we want. And the surface is like whatever the integrand is equal to z. And so, yeah, right. Syntax. I was just like confused because they normally give you things in the right order. So I was worried that I was doing something wrong, but yeah, I'm not gonna, well, I guess we probably should bother. It'll make my brain hurt a little bit less for this next part. Drop in basic algebra, see what you can do. Yeah, that's a good idea too. So if we want dy dx instead, I always start with the inside and then work my way outside. So we need to figure out what y is ranging from. So y starts at 0. And it goes up to this function, which is x equals root y, but we're going to make it y squared because we want x equals something now. So y goes from 0 up to x squared. And now the x is simply going from 0 to 1. Like, from 0 to 1. So once we've accounted for this like curve once, we're kind of done with it. Hey, Bobbin. Joke around with a few people, but nobody's cracked it yet. Nice. And so that's how you would. That's basically how I swap the bounds. I just draw the region and then start from scratch and just kind of re-express it. So rather than x starting from the parabola and going out to 1, y is starting at 0 and going up to the parabola. Yeah, I'm glad you actually asked a question that I can do. I am interested to remember what the condition is. The bounds probably need to be continuous or something. Fubini's theorem, right? Oh, but you need Lebesgue. Frickin' Lebesgue. Oh, wait. Formula is generally not true for the Riemann integral if a function is continuous on the rectangle. So because there's no discontinuities, on the inside over, I guess, this rectangle here, it's okay. There's only a discontinuity at x equals -1. A wedge B is equal to, ooh, that's interesting. We haven't talked about negative numbers in there, have we? Now that I think on it, I should really cut a circular sector out of blank paper, color 3 geodesics with colored heavy markers, and roll it up and try shining a light through to see them. Oh, that would be cool. So you got a less strict form to my conjecture from few streams back. We can try. The version for the Riemann integral Laplace required are stronger. Okay. No going back to real numbers. Is this like in parentheses x plus 2? I guess maybe not. Like, or I guess it's like this. Okay, okay, yeah. Well, this thing evaluates to 4, right? So x equals, I guess basically x plus 4 equals 0. Or have I gone back to real numbers now? I don't know how else you would solve this. I guess, yeah, you do that. But you still have to evaluate this, right? Whoa, so you're making a leap if you're assuming that these two things are equal to each other. I guess like this would be like distributivity. Like that'd be an interesting thing to investigate too. Like, would it be true that 2 times 2 wedge 3 is equal to 4 wedge 6? Yeah. It wouldn't be, right? Okay. Polynomial f of z with complex coefficients For now, let's assume RA equals RB implies A equals B, so no repeat roots. Okay. Okay. I assume syntax is still typing out another piece of the problem here. A squared plus A is equal to, ooh. Really? So that is 4 times 2 is 8. But it's not true that 2 squared plus 2 . Well, I think the issue, Lucas, is that it's going to depend on which one is greater than the other. Or maybe you fixed it now. Okay, so yeah, maybe you could express it more simply as A wedge B is equal to A max AB plus A. Am I doing that right? Yeah. Okay, sorry, I'm just... Oh, and Janie solved the integral we were just looking at before. Nice. We're just the question was just about like switching the bounds, so I didn't bother doing it, but nicely done on Janie. That's not easy for me, Varun. I'm okay. There's a mistake. Okay, I'll paste in what you originally said and then I'll fix it. The IM connection should be or. Not that both are always true. I'll find which part you said that in. Varun, I am okay. After P not equal to K, the same with, okay. Oh yeah, fair Lucas. It might not be, but a lot of math isn't useful. It doesn't have a known use, I should say. But like also like playing around with stuff like that is how you can find stuff that actually does have a use. Um, yeah, exactly, as Fenbox says. And so there might be some like, or there's at least there's some things in math that are really difficult to do stuff with, but are still really helpful. It's like even if doing these basic operations are really difficult, maybe there's some other thing that this makes really easy. Um, I've seen a lot with like in physics with different like coordinate systems. It's really difficult to just like add two vectors, but it's really good at expressing other things. So it's possible that this has some like unexpected use somewhere, but yeah. Yeah, basically. Let T sub k be the number of roots in of f prime z, right? For polynomial with distinct roots, shouldn't it be degree -1? Oh wait, no. Well, wait. Yeah, this is. It should still be degree -1, but I do have to remember these are complex coefficients. The real part of the roots is closer to some. Oh wait, TK are the actual roots. I'm sorry, not the number of roots. Sorry. Okay. The real part of the original's roots are closer to the real part of the derivative roots, so a critical point, well, the real part of a critical point, than any other is, well, what is RP? Because this is for all R sub k, but then I don't understand what RP is. So is K some like particular root? So maybe like I feel like there should be so the real part of R sub K goes to the real part of a root of a derivative. I mean, I bet you could name a polynomial where there's an equal space, or like where there's like a tie basically. Hey Sakno, hope you're doing well. But I might say like then there exists a K such that I think this is maybe what you're trying to say. And I mean I might even say such that the absolute value real part R sub K minus real part is less than like R sub P. Just like put this into math. I think like you're making a statement about distance here. For equal distance, the OR case exists. That's equals well, it should be a repeated root case. Okay. I guess maybe repeating K isn't a good thing here. Like we should use any other letter. But that's not the important part. Um, I don't know. So as I'm interpreting this, like, actually put equations to it. Thinking method on how to combat certain opinions in philosophy. Okay. Minus the repeating the K bit. There's gonna be a whole mess of like letters, but like I was like M is some like arbitrary root there. I guess we can make these M's as well, just to be consistent. And that a P. So maybe something like that. Okay. There's also the actual text if you want it. Sounds like Amorphous is into philosophy and is interested to hear what you have to say, Sock, now. On Janie, a while ago, syntax error is working on something like, was it Rolle's theorem for complex polynomials? It's one of those like Rolle's theorem or intermediate value theorem or something like that, but for complex coefficients with polynomials. And that's what this is related to. Complex representing polynomials have a critical point between two zeros. Okay. Felix, like, it's just what syntax error put above that message. Is that extreme value theorem? I think that's extreme value theorem. Well, yeah, maybe extreme value theorem is a little more general. But I think it's more or less extreme value theorem. Graphing x to the x without Desmos? Uh, probably not. There you go. Yeah. You asked the question, I answered it. I could always like plug in points and stuff like that, but that sounds just like I feel like I'm just kind of being quizzed here, and that's not what I'm here for. Okay, so unless someone has a question, I'm going to go back to doing the studying stuff. Or I assume that's all you needed, syntax. If there's something more, let me know, but unless I'm missing a question, I think it'll be back to study time, unless, yeah, you're good? Okay. I do want to multiply out this denominator here. Well, no, I can just do product rule. So I'm trying to find the residue first around IA. And so when it's a simple pole, there's a really easy formula. We take the derivative of the denominator. And then plug in the pole. So I'm going to do a product rule with respect to k. So we get I b minus ik plus minus I a plus ik. Let me see if FizzBuzz can help me with graph some examples of this. I tried my own with matplotlib. Looked kind of stupid. Yeah, I bet he could. His stream days are normally Monday and Thursday. But I'm sure if you were to like ping him too, he'd eventually have some time. Oop, not Z. That's supposed to be an X, by the way. For K equals IA. Hey, Aniket. Any more saying, Sakana, do you read any works by philosophers who are also mathematicians like Descartes? I would bet a lot that the answer is yes. I know that Sakana is pretty into philosophy in general, but I'll let Sakana answer that. Oh, why did I say that? Why did I swear that? I'm in California, Aniket. This bit here is 0. This bit here B plus A. So the B's cancel. Or the B plus A's cancel. And I'm going to rationalize it. So we minus IE to the minus AX. So then what gets plugged in here is that. So we just get 2 pi e to the minus AX. Oh, by the way, we need 1 over 2 pi. Opca name? I don't know what that means. Writing code, I love that I will eventually add 0 enough as a variable. Oh, yeah. Yeah, it's always an annoying thing. You have to put that like error tolerance in there. Yeah, Felix, I saw you post that question in Zach's Discord. I don't know how you solve a problem like that. I'm sorry. I don't even know where you start. Aniket, I'm just working on studying some complex variables problems. I'm working on Fourier transforms right now. Please speak English. Then Sachna's responding to amorphous. Oh, nice. Okay, so I don't... So I'm not done with this. I'm not even close to done with this inverse transform. I need Jordan's lemma. My phone number? No. Universal only recognizes 3 of those names. Yeah. Do you give your phone number to strangers on the internet, Aniket? Oh, speak of the fizzbuzz. Oh, you know what? Okay, bye, Aniket. Uh, do you think? Oh, you're asking that to Fizzbuzz. Want to do it my way for no real reason. That's very, like, I feel that. So I need to be careful with what I'm doing here. Uh, I need to rephrase my work here. I need to change K's to Z's. Anika, I am a-okay. Kind of comes off Scientology. Oh, that's funny. Okay, and so we also know this is such messy work. Give me half the digits. You can have digits to your phone number. That's a great idea. All right. You're also not speaking English. You're pissing me off in two different ways. So I am officially done with you, Aniket, for the next 24 hours. Take my phone number, add one, what is it? Yeah. You're about to start pulling like the RuneScape like phishing tricks where it's like, oh, did you know if you type your password backwards, the game will start out? I have all the digits to your phone number. You're on to me. I don't know how smart he was. That's crazy to believe. Oh yeah, mathematicians throughout history have a long tradition of being a little crazy. Some more so than others. Okay, so then for this integral here, we need a Mr. Jordan's lemma, Jordan's ligma. Let's screenshot it actually. Let's go a step further. Well, that's the magic of this, Joseph. It's basically all of them at different times. Oh wait, this should be a DK. That's a good catch. It's very easy to get this mixed up if you can't tell. Okay, so as z goes to infinity of this piece here, then the result goes to 0. Yes. So Jordan's lemma applies. I like being 5 years old, by the way, and calling it Jordan's ligma. So we have shown this thing here is equal to 2 pi e to the minus ax. But we implicitly assume something about x here that we need to think about. So this result is only supposed to be true if x is greater than 0. And so when did we assume that x is greater than 0 in this work? I don't know. Oh, so Jordan's lemma only holds... Okay, when we applied Jordan's lemma. Because... Oh, did I delete it? Why did I delete it? Jordan's lemma is only a thing when the constant is positive. So that's when I assumed it. 2 plus 3, 5. Using k for k space is so annoying because I keep thinking k is an integer. Yes, I completely agree with that, Joseph. I don't like k as a variable for a real number. Um, Now I'm a little confused. I feel like the contour has something to do with implicitly saying whether x is positive or negative also, and I'm trying to figure out why. Everybody knows DK is a gorilla. That's very true. There's a whole rap about it. Because the book does say it to get the other piece of the piecewise function, you need to do the other contour that goes under, it goes down under. And I noticed these two have opposite orientations. And I wonder if that has something to do with it. Crikey. I don't know. Like, I'm a little confused on how the integral works when x is negative. Because, like, how do we apply Jordan's lemma? Don't they address this in the book? .2.2. Where? Oh my god, where is it? Here. Just for the lower half circle. Okay. Okay, so that actually, it is all just Jordan's lemma. It does also have to do with the contour. Okay. Can't believe he went from balling to complex analysis. What a genius this Jordan was. Oh, while being a country as well. Yeah, what a goat. Jordan really did everything. How did I compute the residue? Oh yeah, for simple poles, there's a really easy formula. Um if it's a simple pole, the residue f of z is equal to some numerator function over some denominator function. The residue of f of z about some point z naught is equal to n of z naught over d prime z naught. So you just take the derivative of the denominator and you plug in the point. Also a big Lebesgue hater, really. Sokka saying to amorphous. Most of the ideas of stuff like his monadology or sci-fi. Leibniz. Huh. That's interesting to hear Sokka. You know, I don't know who Jordan even was. I think we need to do some Googling because his name is all over certain parts of math. Camille Jordan? Is this the Jordan? Oh my god, he has at least 2 woman names. That's very French. Group theory was influential cool why am I trying to pronounce French words? I don't know. Born in Lyon. You know what? I feel like we kind of look similar, actually. Oh man, that's a good question. Who's your math doppelganger? He might be the closest person who I've seen to me. Jordan curve theorem, a topological result required in complex analysis, Jordan normal form, Jordan matrix, Jordan measure predates measure theory. Okay. Jordan Holder. I think it was Jordan next Halloween. Yeah, I'm sure everyone will get it immediately. I was not saying anything about his life. Come on, the best part of reading a mathematician's Wikipedia page is seeing all the messed up stuff that they were doing. That Leibniz was not intending to have this outcome, but it shows a particular direction where his ideology went. Yeah, I bet that happens a lot. Raheem is asking about the Cauchy-Schwarz inequality. I've barely used it. Jordan curve theorems are the most obvious theorem. That does sound very obvious. I assume it takes some ingenuity to prove it by elementary. Wow. This feels like something you would take as an axiom, to be honest. Theses provide no Jordan theorem use algebraic topology. Okay. Yeah, Arnev. Anshuman, no, I can't. Sorry. Yeah, I don't know what homology theory is either. Um, Arnav, I've tried before. I can't do them. I've still nice for theory building though. Like, why is it obvious what actions to rely on? Fair, fair. Yeah, it's kind of amazing that it's so difficult to prove that. Homology is from algebraic topology. Okay. I was wondering if they were gonna show the elementary means, but maybe not. Sorry, so someone asked about the Cauchy-Schwarz inequality. Honestly, I'm sorry. I've almost never used this thing. I feel like you most use this for competitions or like really. Yeah. Anshuman, if you're preparing for the JEE Advanced, I don't know the tricks that they use, so it's going to be hard for me to give you a hint. Um, yeah, you know, Raheen, I'm sure I could apply this to a problem, but I don't quite know what exactly would help you to hear about here. Because I basically never have to use this. I want to like Cauchy Schwarz for the L2 is self-dual. Whatever that means. Uh, that limit one didn't seem like an advanced one. I mean, oh, it's 56 seconds. Okay, we can watch that then. The audio isn't gonna come through to YouTube. What is this? Is like a meme voice? There we go. People have also done that. Corollary. A Toyota corollary? There we go. It's a nice proof. You can't find anything related to logs? Hey, Storm. What 1807 is in logs? Depends what base you want to use, but you could. General version is the holder inequality. Can also prove that the dual of LP is LQ, where Q satisfies. Oh, okay. Wait, what thing was I just reading about with Fourier? Oh, it's this. the space of square integrable functions is stealth dual. Sure. Read what Sakano was saying on YouTube. There's a ton of ideas that are in philosophy that have been used to abuse. Show why science might be mathematics, which I've been trying to construct this thing on the ethics of. It's imperative for our communities to keep them safe. Some people look at me and say, oh, philosophy is irrelevant. Like, it's not. It's imperative to keep our community safe. Fair, fair. So yeah, Lucas, I'm not sure what exactly you would want to, or what you mean by like 1807 in logs. For any base, like you could say that 18. Oh wait, 1 point. I forgot. That's the you're doing like the European convention where for you a comma means a decimal to me. But either way, the answer is the same. Which is you have to choose a base. Like if I choose log base 10, it'll just be 10 to the power of 1.807, whatever that is. I should maybe put parentheses there to make it more clear. Change my formula for a wedge a to be equal to a comma number. Oh, to be able to get like I guess rational numbers. No worries. Yeah, I guess you'd be restricting yourself to only certain types of rational numbers depending on your choice of C though. Like if you choose C equals 2, you might not ever be able to make 1/3 or something like that. Hey Jasu, hope you're doing well. A stronger version of Jordan theorem where you can show the interior is homeomorphic, fancy bijection to a disk. Huh. However, in higher dimension, this generalization fails. The Alexander horned sphere? I gotta look that up. That sounds like the name of a toad. If like I can imagine there's a toad called the Alexander horned toad. Got a busy week left to send my paper back, so it's busy time. That is fair. Good luck with that and Godspeed to you. Man, this reminds me of something from a movie. I can't remember what the movie was though. Hey, Chaitanya? Leave it to topologists to discover such a weird shape. Two-dimensional sphere. A circle? In three-dimensional space? Oh, wait. No. Okay. God, this phrasing is so confusing to me, but it means a sphere is a two-dimensional surface that can exist in 3 dimensions. No, it's an animated movie this reminded me of. That's an injection of the sphere in R3. Okay. Mostly logs are rational. I don't think so. Or Well, like the output is, I would say it's usually irrational, but usually you're plugging rational things into the base. Well, usually just like natural numbers, I guess. Uh, yeah, Zach. That's what I realized. That the surface of a sphere is only two-dimensional. That's something that like the general relativity book was like talking about a lot. There's a map from that sphere, from the sphere to that horrible thing, and the map is 1-to-1. Sounds crazy. You look at the picture. Yeah, I'm sure they make it work. Oh, that's a cool visualization right there. Just looking at that. A 3D fractal? Is this actually like, would it be continued infinitely? I assumed you could make an infinite shape in topology. At oh my god, you actually okay. That seems problematic. I don't know. Um, by Twitch, you need the word room. Yeah, YouTube's character limit is so much worse. I don't know why. Uh, yeah, Luke, so I'll have to read back your messages through. Let me. Sorry, I'm trying to catch up with other things that are happening in chat too. The Cantor set, is that topological? I don't know. Or what? The only thing I know with Cantor is the diagonalization thing. If the Cantor set is something else, then I don't know it. Chaitanya, I don't know much engineering math. No. Sanji, welcome in. A solution of 8% boric acid is to be diluted by adding a 2% boric acid solution to it. The resulting mixture is to be more than 4%, less than 6%. We have 640 liters of the 8% solution. It's, oh my god, it's one of these chemistry dilution problems. How do you do these again? There's like a system of equations or something. Actually, wait, today's Tuesday. Is Dr. Gold, he might start in an hour. I bet you that Dr. Gold or Actual Education would know how to do this. I'll see if I can figure out. You think 480 liters would do the trick? Yeah, I haven't done this type of problem in a long time, so I'm trying to remember how these work. Um, Usually make a table. Cantor set is your favorite example of an uncountable set with a zero measure, Lebesgue. Okay. Hustle, what are you saying? See, looks. I'll catch up with your chats after I think about this. I think the shape was practical. The shape. I guess it prevents us from making a more general statement. It's a counterexample for a more general math statement that we would have otherwise been able to make. But if you're asking that question with a lot of advanced math, there's not usually a very good answer. Or it's at least a niche answer. More than 4%, but less than 6%. So how do we make how do we set this up? Do we want a total amount like 0.8% or 0.08 times 640 plus something else divided by total volume? Okay, hustle, go bye-bye. We have a 2%. Did the music stop, by the way? That's weird. We have 2% and we're going to add some amount V to it, or some amount V of the 2%. And we're going to divide by the total volume, which is 640 plus V. And we want this to be more than 4%, but less than 6%. And we solve this for V, I want to say. See, okay. See, I'd say if you're gonna have chemistry questions in general, actual education is gonna be a much better person to ask, but this one I can kind of logic my way through it. And so if you want to back up and explain how I set this up, just let me know. Or if you already understand this part, then I won't bother, but we can think of this as like two separate equations and just solve them separately. We also don't... 0.04 is of the whole solution. Yes. And so the entire solution needs to be between 4 and 6% boric acid. And so that we're taking the total amount of boric acid that we're adding and dividing it by the total volume. So I think we've accounted for that with these inequalities. And so honestly, I think this is going to be a little bit easier if we split this into two separate inequalities. I think you could keep them as one and solve them simultaneously, but it'll get a little bit weird. Sophie Germain identity? I never heard of that. Oh. If it's a competition problem, I guarantee you I can't do it. I'm sorry. I don't know competition math. Okay, so to solve this inequality, I'm going to multiply each side by 640 plus v to get rid of the fraction. Thank you, Tinyfold. Sorry that I can't help. I'm going to use a calculator to do 0.08 times 640. That's 51.2. Now I'm going to distribute the 0.04. 0.04 times 640. I should just know that mentally, but I feel lazy. 25.6. Okay, and then I'm going to subtract the 0.02 over here and subtract the 25.6 over here. So 0.02v is less than 25.6, and then divide out 0.02. 25.6 divided by 0.02 with a calculator, 1280. So that's maybe, I guess that's the most we can add. Let's see what we get on this inequality. Abrard, I'd rather you just post it in the Discord than DM me, if you don't mind. 0.08 times 640, we already said is 51.2. 0.02v. Multiply this to the other side. .06 times 640. 38.4. Then subtract this over here, subtract that over there. Oop, not equals. We're going to get 0.04v greater than something. 51.2 minus 38.4. 38.4. 12.8. Now just divide out the 0.04. 320. Okay, so then if we combine these two things, it should be anything between 320 and 1280. Okay, it looks like you got there before I did, which is fine. And so I guess we didn't have, like, from the way the question is phrased, I guess we could have just said any number between these two things. They weren't necessarily asking for the range. But I feel like getting the entire range is the better answer. But I guess you could basically choose any number between here that you want. So so yeah, Sanjit, thank you for the question. 0.05 times 48, since we're on the subject of decimal arithmetic. Obviously dividing by half and dividing by 10. So that's 2.4, Zach? Oh wait, no, I'm sorry. Wait, yeah. Yes, it is. 2.4. I verbally said the operation's wrong, but I think 2.4 is right. Hey, it is. Yeah, suck now. Many of the weird analysis functions are hard to define. A non-measurable function. Hey, Tartar, I'm doing well. How about you? Okay, so I still need to catch up with what Lucas was saying earlier. Let me quickly answer Aditya's question. Because I think that'll be a quicker one. So you're allowed to use L'Hopital's rule anytime you have an indeterminate form, which are these listed here on the Wikipedia page. That's when you're allowed to use it. For the second part of your question is you have to use it on the entire limit. Use apart, but you can use limit properties to simplify it first. So if you like to infinity of some constant times f of x, and f of x fulfills L'Hopital's, you could bring that constant out in front first. Like the only thing that matters is whether this part here meets L'Hopital's. And yes, it's same with like sums and differences. And that question we were doing earlier, I think you were the one who asked it. I use some constant c to the f of x is equal to c to the limit. It was some identity like that. That's a little bit more vague, but I think it's I think it's more like this. I use some identity like that, yeah. Nirmala, PNC, I'm pretty bad with that stuff, I'm sorry. And here, the differentiation of x to the x to the x? I think I can do that. I want to answer Lucas's question first, and we can talk about that if you're able to hang out. Sure, Sanji. Suze asked me to look back through these messages. I to the I, that's a quick one. I can, to do I to the I, I'm going to rewrite this I in polar form. Because I know that I is equal to e to the I pi over 2. So this thing up here is equal to e to the I pi over 2 to the power of I. And when you have a power to a power, the exponents multiply. So e to the minus pi over 2, because I times I is -1. So that's just the answer there. I to the I is e to the minus pi over 2. Actually, Lucas, are you here right now? You are? Okay. I can do x dx as well on dairy, but like I said, it'll be after this. Kind of just say no. This will be a hard sell. So I guess the first thing is that we don't necessarily need the over C, or okay, maybe the thing that's the thing that's difficult about this is that log of a might be an irrational number. Actually, well, I guess. Yeah, so I was just wondering if your wedge thing is defined for irrational numbers. I guess the maximum formula still works, though. Yeah. Tertar. Lucas has invented his own like wedge operation here. Um, Basically, if you have a wedge a, oops, wedge a b many times, this is equal to a plus b. And if you have a wedge b, that's max of ab plus 1. That's how you like evaluate this. Stewart's theorem. Yeah, sorry, I don't really know this theorem. I'm sorry. Um, I don't know how you would go about trying to find a C that would make that true, or if one even exists. Okay, so I'm not sure you're getting the e to the whatever business from. Right. Like you're saying it'll always look like some other irrational number, like not really be a different one. If C itself is irrational, yeah, you can probably get new irrational numbers with that. It's kind of hard to judge. Hey, Shanur, sorry if I'm saying that wrong. Welcome in. That's awesome. But yeah, Lucas, I kind of, I don't feel like I know what I'm doing here. Yeah. Yeah, I'm sorry, Lucas. I don't know what to say about this. I don't know how you begin trying to figure this out right now. It's possible to make an operation where if you repeat it 2 times, it becomes plus. Oh, trying to make like a half addition. Uh, I mean, you could. I mean, I guess it would be like. Um, isn't that just minus? I mean, uh, yeah, I see what you mean with like minus a negative is just plus a positive. You could make something where like if I make like plus with a circle to denote our new operation, you could make it so it's like a plus b over 2. And so if you do a plus b, that becomes your normal a plus b. I don't know, like I wonder, like, is there a book we can find for you that does stuff like this? I feel like that'd be a helpful thing. Like, Anil, you can try me, yeah? I don't, I hate the word algebra. I'm just getting like elementary algebra. That's not what I'm looking for right now. Uh, oh no. Between plus and minus? Or plus and multiplication? Uh, I don't think so. Integration? Yeah, I mean, I don't know every single integral, but you can just try asking a question. A/A/A equals 3a plus 3. So would A/A be 2a plus 2? I guess so. I feel like this is very similar to what you were just doing. But like it is a little bit different. I don't know. Like I don't know what this type of math would be called, like trying to invent new stuff like this. Oh, that's a really hard integral, Neil. Let me just look up how this one is gonna work. Yeah. Neil, are you in like a calculus class or like what are you studying right now? Yeah, so that's kind of a terrible integral that you don't normally have to do. Uh, this is definitely like, I would call this a really big challenge problem. That takes a lot more work than I'm willing to do right now. If you want, though, I can link you to this website and you can see the steps for yourself, too. Yeah, it's just, there's a lot you have to do here, and I don't really want to do it. What about an operation that gives you itself if you do it with itself? So a slash a equals a for an element of R. I can't imagine you'd be able to do much interesting with that. It's like an identity operator, I guess. Okay. See, I've still been to talk about stuff. In the meantime, I'm gonna go back to doing this studying here. Hey Molly, yeah, it is. I have tried JE problems before and I can't do them. Okay, so my work is getting really messy. Getting it is really messy, but I'm just gonna plow right through it. I just want to get the other piece of this just to prove that I can do it. And then I can rest easy. Oh shoot, wait, is the person who was asking about x to the x still here? I forgot. Underi, their name was. Yeah, the JE is India's university entrance exam, and I've tried to do questions from there before, and they're just really tedious and use really weird identities. Well, they have a few different versions of like university entrance exam. The JE Advanced is the really hard one. Okay. Yeah, the J advance is really insane. Eh. Um, that needs a minus sign in front. All right, so I think by the same logic, this thing is equal to 0 by Jordan's lemma. But the I is bad. Oh, I just dropped the I when I shouldn't have. Okay, and then this does work out. Okay. But I can finally say that I understand the first example in section 4.5. Oh wait, no, I didn't even do it right. Or not anything about x equals 0. Bruh. I forgot to think about these. Well, actually, no, I don't know how you get... How do you get the bottom result? Also, I've gotten like these top, like that result and that result. Do I want to check 40, choose 16 cases by hand? Is that what you're doing right now, or is that related to this problem? Oh, yeah, good luck. I guess, yeah, with your exam. Hey, Licketh. You're writing a Python script for that. Okay, nice. Yeah, Licketh. $62 billion cases? Really? Oh my god. No, you guys are good. Neil, you know. Find among 40, choose 16 lines that are disjointed. If 0 and infinity were at the same point on a looped number line, what would 1 over 0 equal? Well, is that a quick question? If 0 and infinity were at the same point on a looped number line, what would 1 over 0 equal? Anil, almost nothing. I'd rather talk about math. People have asked me questions like that before, and it just causes arguments, and so I'd rather not talk about it. Sachin, I I think there's a problem in saying 0 and infinity are the same point. I feel like you would need to choose one or the other to be that point. So I have a hard time answering that question. Maybe I just don't understand what exactly you're doing with that, but having one point be two different things seems problematic to me. Why is this integral equal to 0 for negative x? Because it's not enclosing any poles. Okay. And likewise with the opposite. Okay, that's reasonable. Yeah, I'm from America, but like I said, can you just keep it to math, Anil? Okay. I nearly understand all of this first example. I just want to work out the x equals 0 case, and that should be quick, I think. One over 2 pi e to the wait, if x equals 0, that's just 1. Okay, so basically 1 over 2 pi integral minus infinity to infinity 1 over a plus I k dk. Okay, and so 1 over 2 pi times 1 over I ln. This is I guess with the absolute value. Well, that's a problem. No, it's not a problem. It's absolute value. So isn't it k? What? How do you evaluate this? Should I literally make this like root a squared plus k squared? But I think the issue is we have an infinity minus infinity situation. Thank you, Fembox. There's a discontinuity in this thing at 0, so we need to actually do from 0 to infinity plus from minus infinity to 0. I don't know if this will actually fix it or not, but sequence and series harmonic progression. Can you be a little more specific? Can you give me an example of a question? We still have to get pi out of this in order for this to be 1/2. I don't know where that's going to come from. Well, I don't know what's basic to you. That's kind of. I've had many people ask me general questions like that before, and I end up talking about the complete wrong thing that they didn't mean to ask about. So that's why I don't like. What the heck? There must be something wrong with this. I really don't. You know what? Can Wolfram Alpha actually do this integral? Can it do the do? Wow, you get pi? Only the principal value integral converges? That seems problematic. Those my operations, this sucks. Hey, think twice. Uh... Hi, Dr. Cook, but I think the book actually did that somewhere. At least one like that. It'd be an interesting one to try though for myself. Oh my god, this section is so... I mean, maybe it's in the next one. I don't know. Yeah, look, I don't know why you all are up at this hour. Oh, Hershey, if you want, you can post your problem. No waffle stompers allowed. Oh, yeah, Hershey, that doesn't look like a question that I can answer. I don't see why. Oh, because of the factorization, Puika? All right, see you, Looketh. How does a function involving I even have an area? Uh, it doesn't. Not in the normal sense of how you would think of it. I don't really even know the how you interpret this, to be honest. um, yeah, it looks like it. So think twice. I generally can't do JEE questions. I don't know if that's an exam that you're studying for or not, but in general, I have a bachelor's in applied math. I can do things that are like um undergraduate math and below, and best of like calculus and like uh and below, I guess, though. Integrating complex valued functions similar to integrating complex vector valued functions. I guess that makes sense, Territar. Okay, maybe I should throw this away. I should just rationalize, right? I didn't think about doing that. Oh, that makes it worse, doesn't it? No, I mean, not necessarily. Anil, no, that looks terrible. Advanced algorithms? Uh, Probably not. I know a little bit about algorithms, but I have a feeling I can't do whatever you're working on. How does that arctan work? I can never remember this, man. So I want it to make that a 1, so I factor an A out. My most powerful stream in math? I don't know what you mean by that. That doesn't feel right. I feel like it should be a squared on the out front. No, it's not. Okay. So that a cancels, becomes a 1. I guess calculus? If you're asking like what I feel the most comfortable with. Like first year calculus. So arctan to infinity is pi over 2. Arctan to minus infinity is minus pi over 2. That's what I'm thinking, Pop. We still have this annoying ln from minus infinity to infinity business. You don't think your Python will ever finish? That is a lot of cases. So this should equal 0. This seems annoying to actually prove though. Okay, well, let's take this thing separately. So we have an absolute value. And so can we say this is equal, oops, to ln no absolute value if we go from 0 to infinity? Do we need to do it times 2? I think times 2. It's an even function, right? Yeah. Then we're not going to get 0. And I want to get 0. I wonder if this is even true. I feel like is x squared from, well, that doesn't, is x squared from -1 to 1 equal to twice of x squared from 0 to 1? That's what I'm curious about, I guess. It's not. Juan Mata? Oh. Fucking hell, I'll take that. I'm gonna tell everyone I know that someone said I look like this guy. The Ed Sheeran I've gotten before, yeah. Well, yeah. So I'm doing the B to infinity thing in my head, and it's just oh wait, well maybe hmm maybe it is just that. This I guess so. Oh, I mean this is just already zero, isn't it? Like it's just ln of something minus ln of the same thing. I guess that's why the Cauchy principal value converges, but not the regular integral. That's a lot more subtle than than the book let on. Uh, where was this from? Fourier. The values at x equals 0 take into account both the pole and the principal value contribution at infinity. Wait, what? Why do you need a contour for that? Will I stream tomorrow? No. Not, I mean, I'm gonna stream video games just on Twitch, but I'm not doing a mass stream. And I want to do this entirely other way with a contour. I think I'm really beating this example to death, though. Contour addicted. Mm-hmm. Day after tomorrow, yeah. Both the pole and the principal value contribution. All right, see ya, Neil. What does the principal value contribute? I don't know. Or I think I know. I don't know. I think I know. I don't know. That makes perfect sense. How to improve geometry? Just like anything else, all you can do is practice. It's not really a trick. Any tips for JE? I do not have any tips. No, I'm sorry. I I can hardly tell the questions for myself, so. Okay, so they're introducing this delta function, and they're going to let epsilon go to 0 to make it the Dirac delta function. It makes sense that that's both absolute and square integrable. I mean, yeah, that's kind of they always throw curveballs with the question, but like all you can do is hope that you've seen it before, and that you know like what the tricks are. So that's why the practice is important. Entrance exam for MIT also? I don't know. We have some general entrance exams here. I don't know if MIT has their own one. The integral from minus infinity to infinity of this function shifted by some amount is equal to my major is applied math. Isn't this also a like I was thinking this as I was reading this the first time. Isn't this also like a probability density function? This would be like a uniform distribution. And I was wondering why the 2 is there. I imagine that's to make this property be true. Uh Because what would happen when you actually integrate it? That's just a constant. So it would be 1 over 2 epsilon times x, where x goes from minus epsilon to plus epsilon. So yeah, you do need the over 2 there to make this property be true. Oh, nice, Bashar. Spectry, 28 months. Oh my god. You know, after the number 9, if you subtract each digit individually from the number, it is always divisible by 9. Wait. What? Subtract each digit individually? Oh. That's interesting. I have not heard that one before. So if I have 143 and I do 143 minus 1 minus 4 minus 3, what is that? 8? 135. That is divisible by 9. That's weird. I know 9 has some weird like properties. Like I feel like I've heard other properties with 9. Well, yeah, we've done 2 examples and it works, which means it must be true. Hey, Advin, well, welcome in. But yeah, thank you so much, Spetri, for the sub. The OG. You have another one? Hit me with it. After number 9, subtract each digit individually from the number, it is always divisible by 3. Well, yeah, if it's divisible by 9, it has to be divisible by 3. Well, the part with 3 isn't too surprising because we already established that for 9. Territory tried with 111? Okay. I bet there's a way that you can show why this works. The proofs involving digits are always super weird. Like you would take some number A, B, C, D, or I don't know. Like, could we show it just for like 3-digit numbers? Like, let's say we have a 3-digit number ABC. Can we show that ABC minus A minus B? This is terrible notation though, because this looks like A times B times C. To show that 100A. Right, that's a better way of saying it, yeah. show this is divisible by 9, which seems like a... Well, oh wait, maybe that's not so hard. 99a minus 99b, that's divisible by 9. That's actually kind of slick. And that would extend really easily to any number of digits. I I don't know about the word love. Oh, I don't know how math works. Oh my god. Yeah, that's a crazy typo to make, Bashar. Thank you for catching that. I'm just going to reply to this text quickly. Okay. Was more important than us. Random person on Facebook Marketplace who just messaged me asking if they can buy the last thing that I'm trying to sell. And they're probably, and like most people, they're probably just never going to reply for some reason that is infuriating. I've had some people ask me if something is still available, and I say yes. When do you want to meet up? And I just never hear back. You get jealous easily? Yeah, I don't blame you. Oops, what did I just do? I hit end instead of delete. But yeah, so I was hoping that if I replied quicker, that they'd be more likely to actually reply back. I had one person message me at like 3 in the morning. Other than that person, I've generally been pretty quick, though, I guess. Um, oh, you know what? It's funny. This also looks like a Gaussian distribution. I wonder if there's some kind of connection. I mean, I guess the connection is just that it integrates to 1 over its domain. Wait, so they're saying that delta is not an L1. What was an L1? Oh, capital delta is. Oh my god. Oh, sorry. Just bumped my mic. The person actually replied. We've got a live one. Can't type worth a crap. Okay. Proud of myself for not reading my address out loud as I was typing it. um, just I don't know what to call it. Like it's like a little table thing. It's the last thing that I want to sell before I move. So it's gonna be nice to actually get that out of here. Daniela, I do a little bit of tutoring. Um, I'm not an actual like teacher though. Oh yeah, you're still comfortably in the lead. You're exactly doubling Jet, it looks like, too. Eldritch did manage to get the first, just this stream, though. Yeah, I think you both have gotten a few. But yeah, the competition has been a lot less fierce. There's been some streams where it's like 1 or 2 hours into the stream before someone claims it. Books for self-learners. Oh yeah. Um yeah, so it depends. There's two sites I would recommend. For more like early math, I'd say, or like fundamental, maybe OpenStax has a lot of good books that are free. Um, if you want more advanced books, in finding the website, um, this website right here has actual university textbooks that are free and legal to use, which is great. So you can just like go down to the math section and like algebra, analysis, applied math, calculus. They don't have like everything, but they have a really good variety considering it's all free. But yeah, so I've been self-learning a lot of math, and I just kind of pull a book from here if I'm interested. The Gaussian solves heat equation, direct function models a rapid heat source on a boundary of a rigid body, if I remember my PDE correctly. Its connection, heat equation, Fourier analysis, and delta. Oh, that's cool to hear, Bashar. I know that like a Fourier series is this solution that kind of pops out of the heat equation. Um, that would make sense if the direct function would do that. Yeah, that could be an interesting like boundary condition. Like how does the heat in the rod behave if you just do a little burst of heat like that and let it distribute? I guess it might not be that exciting. Yeah, that's exciting. Now I'm saying like if you had just a little like burst of heat at end of the rod, it will just kind of naturally like diffuse out throughout the rod and become the same. For whatever reason, I thought it might do something weird, but it just kind of, I think, would do what you expect it to do. Yeah, I have to get in and learn more about PDEs. I have learned the basics with like the heat equation and the wave equation, and I think one or two others, but it's been a little bit too long for me. Daniela, oh yes, sounds good. On this channel, it's mostly just like the recordings of these streams. I did at one point make like 2 standalone videos, but they're not very good. The other math channels I would recommend who do stuff like this are Actual Education, aka Dr. Gold, and Academy of Useless Ideas. Salsa PDE? What is salsa about it? Oh wow, the name is actually salsa. No worries, Daniela. Diffusion. Symmetric random walk comes up in this? Huh. Wow, is this all... This is all diffusion. Holy crap. Application to finance? Wow. This book looks really interesting just from scrolling through this. Oh my god, they cover so much. Daniela, wealthy, interesting username. Yeah. Oh, there's even bookmarks. They're not very good bookmarks, but I just want to see how, like, how are random walks related to PDEs? That sounds so random. Ugh. What was the book page? Okay. 43 book page. I'm gonna guess that's like 100 PDF page. Nope. I'm gonna guess that's 75 book page. I'm gonna guess that's 60. Here we go. Trying to manifest it. I respect it. Huh. Approximated by difference equation. That makes sense, I guess. Uh... Hey, Mary. If I'm saying that right. Maybe Mari. I'm doing good though. How about you? If you like, feel free to put your question there in chat. Oh yeah, I was just looking through this just out of curiosity. I'm gonna actually save this quickly. The gamma function, I only know the basics of it, but I can tell you what I know at least. So what the gamma function does is it's called the analytic extension for the factorial function. And what that means is factorials only make sense with natural numbers. Like you can only plug in 0, 1, 2, 3, 4, 5 with the factorial. The gamma function works for nearly any real number. The only ones it doesn't work for are negative integers. You can see this is a graph of the gamma function here. And there's these vertical asymptotes at the negative integers. And it has this integral definition. And I remember like it basically, in kind of a neat way, it uses integration by parts and the power rule for taking derivatives. To kind of reproduce a factorial, but for any number, almost any. Visually, what do the curves tell us? Well, I guess like it's kind of, if you were to graph the factorial function, you would just have like a single dot at 1, a dot higher up at 2, a higher up dot at 3. And so on like that. The gamma function allows you to kind of like connect the dots and fill in the picture, but I'm not, that's kind of a good question. Like I don't know what exactly it would mean like over on this left side. Like this is kind of weird behavior that I don't quite know what to make of. It is a Greek letter. Math is just littered with Greek letters, for better or for worse. So yeah, like it definitely has a, oh yeah, this is a better image. So it definitely like has a clean interpretation for kind of like going off to the right. It's representing how the factorial function grows. But on the left side, it's kind of a crapshoot. I don't really know. I don't know what to make of that. I think it's more of like a happy accident where someone found that this formula works for the like the positive part off to the right, and then the rest is kind of whatever it happened to be. Known as motivated study. No, the gamma function has some uses. I can't remember where, but Mari. Yeah, we can think about that. Okay. And I'm still happy to talk about the gamma function more, Daniela, if you still have a question about it, to the extent that I can answer it. For now, I'm doing this one, but I'm happy to like come back to it if you ask. Gamma and beta function is tree somewhere. Oh, interesting, Bashar. Yeah, so just out of curiosity, oh, okay. Sounds good. So these are always annoying to factor whenever the leading coefficient isn't 1. When the numbers are low enough like this, what I do is I think about what like the factored form has to look like. So in order for us to have a 3a squared here, one of the things on the right has to be a 3a, and the other one is just an a. Because that would get 3a times a is 3a squared. So that settles that piece of it. Now, I also know that whatever goes here times whatever goes here should equal positive 2. So the only options there are 1 and 2. And so now it becomes a game of mixing and matching. So I'm going to guess that it looks like this, and I'm just going to guess, and I'm just going to multiply it back out and see if it matches. I think I intentionally chose the wrong one. I think this is not going to be right. But let's multiply it out and check that. So 3a squared plus 3a plus 2a plus 2. So yeah, this is wrong because the 3a squared is right, but in the middle we're just getting a 5a. So not that. That means we should try the other option. I'll write it separately out here. Let's try switching the 1 and the 2 and seeing if that works better. So 3a times a is 3a squared. 3a times 2 is 6a. 1 times a is a, and then plus 2. There we go. And so it's a little bit tedious, but this is how I do it personally. Sounds good, Daniela. I'll see you around. Thank you for the question. So yeah, that's how I do these. It is kind of tedious to have to check these manually. Thank you, Bashar. Oh, that is another way of doing it, to do it without guessing. We can talk about that too. Let me just talk a little bit more about this, and then I'll go into that. So the only issue is that this can get complicated depending on what the numbers are. Let's say if there was a 4a squared here instead, this might not factor, so I wouldn't do this exact example for it, but if this is a 4a, that means we have choices for what to put here and here, because it could be 2 and 2, but it could also be 4 and 1. So you're getting more things that you have to guess and check. So it does get more and more complicated. The same goes with, like, if instead of a 2, if that's a 6, it could be 1 and 6, or it could be 2 and 3. And you have to check all the combinations. So it does get out of hand. Lucas, in my opinion, applied math. That's why I'm trying to study it more. I think it's, usually people who study math prefer theoretical math, though, to be honest. And so let me show actually one other way. So this is the nuclear option, but you can just slap the quadratic formula on that thing. And I'll show you what to do with it after you do that. So if you do the quadratic formula, so it's minus b plus or minus square root b squared minus 4ac all over 2a minus 7 plus or minus, that's 24. 49 minus 24 is 25. over 6. So we get negative 7 plus or minus 5 over 6. So if it's negative 7, we get minus a third. Right? Yeah. If it's... Oh, sorry. If it's negative 7 plus 5, we get minus a third. If it's negative 7 minus 5, we get minus 2. And so with that result, what you would do is you would say it's 3a squared plus 7a plus 2 is equal to a minus one of the roots times a minus the other root. And oh wait, this is slightly wrong, isn't it? The nuclear option is dropping a bomb. It's true. There needs to be a 3 in front here, doesn't there? I wonder why that 3 needs to be there. Yeah, I don't have a good explanation for why it needs to be there. I know it should be there. No worries, Mari. Yeah, this is a really tricky thing to learn at first. If you're good, feel free to tune out, or you know, you don't have to pay attention to the next part if you don't want. But Bashar did suggest a third way that I'm just gonna explain it for fun, if nothing else. Oh yeah, that's fair, Lucas. Yeah. We know that any quadratic can factor as, oh, we're already using a, some number c times a minus one root times a minus the other root. And so what I can do is I can multiply this right side out. A squared minus so I can multiply the right side out. I did that in my head. This way is a little bit more complicated to understand, to be honest, but you don't need guessing, at least. If you multiply the entire right-hand side out, what we can, the trick we can use now is called equating coefficients. We know that whatever is in front of the a squared on the right side, so in this case c, should have to be the same as whatever's in front of the a squared on the left side. So we should know that this 3 here should be the same as c. And we can make the same argument about the a's. The 7 here should be the same as the minus c x1 plus x2. And finally, the constant 2 should be the same as the c x1 x2. And so this is a system of equations that you could solve with substitution. We already know that 3 equals c off the bat, so we could plug that in. Like I said, this is a little bit more complicated because you have to solve this now. But this is like the no guessing way. Honestly, I'm just going to leave this here unless you tell me that you really want to see it, but this is another way. Completing the whole square method. I mean, I know about completing the square. I don't know how that helps us get it in factored form though. Like this. Complete the square would get in like vertex form, right? I forget what Horner means, Lucas, I'm sorry. No, Bashar, I don't know how it's derived, to be honest. I know that geometrically, like the minus b over 2a part gives you the x coordinate of the vertex, and then the discriminant is like how much you offset. I don't know how you arrive to that though. The way to factor third degree functions, you can also use it for second. Oh, okay. By completing the square? Oh, really? I'd have to see it. If I look up Horner, I don't think it's going to come up as the issue. Oh, that's really... Oh. That doesn't seem that bad. Because even the factors are not natural or real. Yeah, it does. That's actually not as bad as I thought it'd be. Um, okay. I'm not going to show it. If I Google Horner, Horner math. Oh, that's an actual name? I thought, oh. This is a lot of letters, and it's getting towards the end of the stream, so I'm starting to like blank out on this. But I guess you somehow find the first row and then you just like divide it out is the idea. Oh wait, is this just synthetic division? It is, okay. Okay, then I have learned this just with a different name. Do they not use the words synthetic? Oh, okay, yeah. Oh wait, Horner's method involves synthetic, but it's not just synthetic, maybe. It can be shown to be equivalent to Horner's method. Interesting. Okay, fair enough. All right, see you, Bashar. Thanks for hanging out. Okay. We're just about at the 4-hour mark. That might do it for me too, to be honest. I think we had some good chats today. The Wikipedia page was saying that it's equivalent to synthetic division, but I think Horner's method is phrased differently. I already closed out of it. I don't feel like we're reopening it, but I think it ends up being the same process as synthetic division, just with different notation. But yeah, I think that's gonna do it for me. Any announcements? I guess the current plan that I'm thinking is my last stream before I move will be on Thursday with a math stream. I wanted to stream on Friday, but I feel like I'm gonna need that data pack the more that I think about it. So, yeah, I know it is so soon. And then I on Saturday I'm moving out of my current place and moving in with my mom for a few days. And then on Monday we actually start driving out. We're gonna make a pit stop in Oregon for a night and then get to Seattle on Tuesday is the plan. Packing for a trip right now, it's overwhelming. Ooh, that's awesome. Every trip goes well. Getting too little sleep lately. That's why you're vague on math. That's fair, Lucas. So yeah, and then once I do get set up and return to streaming, I'm not gonna have a schedule. I'm just gonna stream when I feel like it, I think. Thank you, Lucas. Yeah, I'm sure I'll be posting pictures and stuff on the way. But yeah, I made it more detailed post in the Discord about what's gonna happen once I return, and with like the dates and stuff. But yeah, so the plan is just a video game stream tomorrow, and then math stream again on Thursday, and then I'll probably be it for at least a week, probably longer. So yeah, YouTube stream, I'm cutting it off here. Thanks everyone who's here on YouTube.